In this video, I'll be working from the Cisco CCNA Lab Guide, which is a free download from Flackbox.com. It's put together by Neil Anderson. And this video is going to be covering spanning tree troubleshooting. And for this video, I'm going to have to walk through using the answer key because I got lost when I was just doing the lab exercise. We'll start there. It says spanning tree is enabled by default. Oh, and by the way, this is lab 15 in the guide. So it says spanning tree is enabled by default, so the troubleshooting lab comes before the configuration lab for this section. In this lab, you will troubleshoot spanning tree for a small campus network. And it says, important before loading the lab exercise, disable show link lights in Packet Tracer. Click Options, Preferences, and so we'll do that. I've already got it turned off here though, but just in case you know, Options, Preferences, right here, Show Link Lights. See how they're there, and then click that to turn them off. Okay, so that's already done. And then the instructions, it says, the Network Operations Center has reported that traffic is not following the most direct path from the branch office PCs to the internet. Your task at this stage is to verify this. Your task is to report which path traffic is currently taking from both PC1 and PC2 to 203.0.113.9. So up here. Do not change any configuration. And I definitely needed help, so we're going to work from the answer key on this one. So let's shrink this down a little bit so we can see our packet tracer a little better. So he starts off by saying there's not a set order of actions to troubleshoot, and he's just going to give us one logical process. So it says check which router is the HSRP active gateway for the 10.10.10.0/24 network, so down here. And we want to see which router is the active gateway. So we'll go to R1, and we're going to pull up the command line. And enable, and then we're going to do the show standby command. Oop. And we will see, if we open this up a little bit. So active router is local. So R1 is the active router. Standby router is 10.10.10.3, which is router 2, 10.10.10.3. The priority of router 1 is 110, so that's been manually configured because I believe the default is 100. And that's what we need from there. So we check that HSRP, the active gateway, is router 1. And it does say here, oh, also we notice that preemption is enabled. So there it is, preemption has been enabled. So the next step for us was to check that PCs have connectivity to 203.0.113.9. So we want to make sure we can get from here to here, and we'll do that. So we'll want to ping 203.0.113.9, and this is from PC1. And let's see what we get. Okay, we have response, that's good. And then PC2, we're going to do the same thing. And we're going to ping 203.0.3.9. Yep, we're getting a response. That looks good. And then it says check which layer 3 path the PCs are using to get to 203.0.113.9. So run traceroute on both PCs. We'll do that. And prompt traceRT in Windows is the command. And 203.0.113.9. So we'll see that the route it's taking from PC1 is through 10.10.10.2, which is right here on router 1. Up to 203.0.113.9, which is here. So PC1 is going this way. And then PC2, we're going to do the same thing. We're going to issue the traceroute command. and for 203.0.113.9. And PC2 is taking 10.10.10.2, which is again router 1. So PC2 is going up through router 2. Okay, and it says the PCs are taking the most direct path via their default gateway. It says layer 3 configuration and operations all look good. So up here we have layer 3, which is where the routers are, and then layer 2 down here where all our switches are. All right, now it says to check which VLANs the PCs are in on the ACC3 and ACC4 switches. So we'll jump to ACC3, open that up, and enable, and then show VLAN brief. I can type today, and we will see that PC1 is out F01. There's fast Ethernet 01, and it is in VLAN 10. And then we're going to do the same for, or actually over here, PC2 is out F01 on ACC4. And let's take a look at that. Enable, show, VLAN brief. And we should see, yep, F01 is right here. And PC2 is also in VLAN 10. All right. It says on CD1 and 2, which is here and here, check the switch ports connecting to the routers have also been configured as access ports in VLAN 10. So it wants us to make sure that the connections to the routers are set as access. So let's do that. And we'll go to the command line. And we're going to do enable and show run for show running config. And we're going to be looking for board G01, which will be this interface. And right here is gigabit 01. Switch port mode is access, so that's confirmed. And then we're going to do the same for G01 on CD2, right? Yeah. So command line, enable, show run, and so we're looking for, what interface is that? That should be 01, G01. And switch port mode is access. Right, so we've confirmed that. We check the switch ports connecting to the routers have also been configured as access ports in VLAN 10. So yeah, we just did that. So 01, it's VLAN 10, it's access. That was CD2. And then CD1, we saw, or 01. You have VLAN 10, yes, access, yes, that's done. It says on all switches, check the interfaces connecting switches have been configured as trunks with matching VLANs. So now we need to check all the different connections from each switch to make sure that the ports are configured as trunks with matching VLANs. So we'll start at CD1, and we're going to do show run config. And let's take a look at the ports there. So we have, first for CD1, we have G01, and that's here, 01, VLAN 10, yes, and, or no, 02, I'm sorry, 01 is going up to the router, 02 is going to the other one. So there we go. 02 is, that's on VLAN 199, and mode is trunk. Okay. Okay, so that's the native VLAN. Okay, and then CD2, or actually, yeah, let me just look at that. CD2, G02, VLAN 199 trunk. Okay, yeah, that matches. Now let's look back to CD1, and we're looking for F021 down to ACC4, 021, VLAN 199 trunk, and then let's look at ACC4, show run, and F021, native VLAN 199 trunk, so this is correct, that matches. We need to look at that one. On CD1, F024, right here, VLAN 199 trunk, okay. And then from ACC3, we need to confirm that. Show running config, and that's 024, VLAN 199 trunk, yep, that matches up. On all switches, check interfaces. Okay, so I would need to actually go, but we can see right here, it says everything looks good, so I'm going to skip that for the video anyway. So we check those. All right, so the next thing to verify is spanning tree. One of the central core or distribution switches should be used as the root bridge to ensure layer 2 traffic uses the most direct path over the network. Check the spanning tree topology for VLAN 10 on switch ACC3. All right, let's do that. Now we're going to do a show spanning tree VLAN 10. And we'll open this up a little bit. And we see this bridge is the root right here. So ACC3 is the root. And we have okay. Let's see what it has to say about that. It says ACC3 is the root bridge, which we're confirming. This is not good. Check to see if this is because it has been configured. It has a configured bridge priority. Okay, so we'll do that. You do show run, which is show running config, pipe it out to include command. So include anything that has the term priority. Nothing came up. And then it says bridge priority has not been configured on ACC3. Check the other switches. So we need to do the same thing to the other switches. So we'll jump over to ACC4. We're going to do show run. Excuse me. We're going to pipe that out to include priority. So basically just saying include any line that has the term priority. Nothing. Let's go to CD1. And we're going to do a show run, pipe it out to include priority, nothing, and finally CD2, show run, pipe it out to include priority. And so nowhere do we see priority being set in the running configurations of any of the switches. So we check the other switches and it says bridge priority has not been configured anywhere. So the switch with the lowest MAC address should be selected as the root bridge. So this should have the lowest MAC address. We learned that ACC3's MAC address ends in D43D, and we can see that right here. Open this up a little bit. And it says this bridge is the root, and here is the address, D43D. So yes, we confirmed that. Okay, verify that all switches have matching spanning tree root bridge information. They should all have the same default bridge priority value as one was not manually set, and agree that ACC3 has the lowest MAC address and is the root bridge. Okay, so to do that, we'll open these up. And we'll do a show spanning tree VLAN 10. Okay, and I'm going to put that right there for now. And then I'm going to pull this one up. Show spanning tree VLAN 10. Put this over to the side for a second, and then CD, and then ACC3. Show spanning tree VLAN 10. And put that to the side, and then ACC4. Go spanning tree VLAN 10. All right, and let's do a comparison. So we remember ACC3 ended with D4, its MAC address was D4, D3. So let's look at CD1 and CD2. And they are showing this over a little bit more. There we go. So the root is D4, D3. Yep, that's showing on CD1. CD2 is showing root as D4, D3, or D4, 3D. Yep, that matches. So those two match. And then ACC4, the root, right there, D4, 3D. So they all match up. Okay. So we did verify that all switches have matching spanning tree root bridge information. This is just going through telling us, yes, they agree, they agree, they agree. Okay. So ACC4's MAC address, it agrees that ACC3 is the root bridge. All right. So we were asked to report on the forwarding paths currently being used. Use the output of the show spanning tree VLAN 10 commands on each switch to diagram the spanning tree. ACC3 is the root bridge, so all its ports are designated ports. So we can grab a little label and we can type P for that one and move that over here. And we'll do another label, DP for this one. And we'll put that right there. And also this one will be DP. And we'll put that right there. Okay, so we have all the designated ports on ACC3 labeled. Since it's the root bridge, all its ports are designated ports. And now it wants us to add each switch's root port to the diagram. And the root port value in the root ID section of the show spanning tree VLAN 10 output. So we'll start at CD1. And if you look right here, so root ID, and then the port is 24. So 024 on CD1, which is here. So that's the root port. So we're going to make that label. And we're going to put RP there. So there's the root port here on CD1. I'll move that over a little bit. And then CD2, its root port is 021. So that's CD2. This is 021 here. It's labeled on this end, but not this end. But that's going to be the root port for that one. Move that over a little bit. Okay, so we got CD1, we got CD2, ACC4, root port is 24, 024, so ACC4, root port's going to be right here. Let's move this out a little bit and up. There we go. And so we got the root port for CD1, we have the root port for CD2, we have the root port for ACC4. ACC3 is the root bridge, so those are all DPs. All right, and it says here now, the port on the other side of root ports is always a designated port. So as you can see, root port, designated port, root port, designated port. And label F024 on CD2 as a designated port. Okay, yeah, because here's the root port. So this is a designated port. So let's label that DP. is labeled. The links which are left must be blocking. These are, so CD1 gigabit 02 to CD2 gigabit 02, so this is a blocking. And CD1 F021, which would be this interface, to ACC4 F021. So this should be blocking. And then this should be blocking is what it's saying. Check which side is blocking from the output of the show spanning tree. Okay, so we can do that. And we'll see here G02 on CD1 is blocking. So we could label that as blocking. We'll just call it BLK. So that'll be right here. And then CD1 G02 to CD2 G02, okay, got that labeled. And CD1 F021, so let's look at that. F021 is, so it must be blocking on this side. F021, there it is. Yeah, it's blocking on ACC4. So let's label that as blocking. We'll call it BLK. All right, it's getting a little bit messy. All right, CD1 G02 is the blocking alternate port. Yeah, we know that. CD2 G02 is the forwarding designated port. CD1 F021 is the forwarding designated port, and ACC4 F021 is blocking. Yeah, we got that marked. So we added that information. Yep, added the information in the diagram, did that. And it says, by removing the blocking links from the diagram, we can see the spanning tree. Okay, so let's do that. So let's get rid of this blocking link, and let's get rid of that blocking link. Let's see if it matches up. Yep, looks the same. We can see that PC1 will take the path PC1 to ACC3 to CD1 to R1 to reach its HSRP default gateway. This is the most direct path and is good. The end-to-end path from PC1 to 203.0.113.9 is PC1 to ACC3 to CD1 to R1 to SP1. Okay? And it says PC2, however, will use path PC2 to ACC4 to CD2 to ACC3. So it's going to come up, over, back down here because this is the root bridge. So it's going to be directed back that way to CD1 to R1. And this is not the most direct path. This traffic is transiting CD2 and ACC3 rather than going directly over the link from ACC4 to CD1. The end-to-end path from PC2 to 203.0.113.9 is PC2, ACC4, CD2, back over to ACC3, which is the root bridge, to CD1 to R1 to SP1. And it says we can verify the path being used by checking the MAC address tables on the switches. First, verify the HSRP virtual MAC address, which should be 10.10.10.1. So let's go to router 1, and we're going to do the show standby command. Enable show standby. And we see the virtual IP address is right here, 10.10.10.1, yes. And the virtual MAC address ends in AC01, and that matches up what they're showing. All right, it says then clear the ARP cache on PC2 and ping the virtual IP address to generate traffic. So we're going to go to PC2. and open up the command prompt and issue that command arp -d and then ping 10.10.10.1, which is the virtual IP address. So we get that. So clear the ARP cache on PC2, ping the virtual IP address to generate traffic. We did that. It says then check the MAC address table on ACC4. So we want to check the MAC address table here. And we'll do the show MAC address table. Okay, and we can see that the HSRP virtual MAC address AC01 is reached through interface F024. So F024, and that was AC01, which is right here, this line. And we can see that it is reached through interface F024, yes, to CD2. So, yep, F024, which is here, goes out to CD2. And it says rather than on the direct link to CD1 over interface F0. Remember, we removed these just to show the route, but there actually is a connection. There would have been a connection here, so it's shown it went that way instead of directly over this way. We can go hop by hop using the show MAC address table command to verify the traffic path end to end across the switch network. Okay, and that's the end. We don't need to go hop to hop doing that. So basically that's what we have. We walked through the answer key because I was lost on how to really get started with this part. But anyway, we're able to see how it's configured, and we can see that it's misconfigured because this should not be the root bridge. So we will probably address that in the next lab, which is the spanning tree configuration. See you in the next video.